So we are still on finding the solution of a differential equation. So with this one, we are saying that assuming that a differential equation has been given to us for us to solve, we need to check a certain condition before we can choose a particular method to solve the differential equation. So here we are saying that if a differential equation is given to us and if we can write it in this form, then we can say that we can use the separable method to solve. Assuming that the separable method didn't work, then it means that we need to also check the exact method. We are saying that with the exact method, if the differential equation is in this form, m of xy dx plus n of xy dy. Now here you can see that there is no way we can write this one in this form, which means we cannot separate the variables. Here you can see that the unknown variable are mixed with the independent variable. So in this case, we need to check a certain condition. With the method of that, we need to use a sufficient condition. So if the condition holds, then it means that we can use the exact method. So this is what we are talking about. If you want to use the exact method, we check for this condition. So here you can see that I didn't miss them. We have a way of writing this. So you will check the function which is attached to the x. So here m is attached to the x. So we will differentiate m with respect to the other variable. So here the other variable is what? Is y. So that is why I've differentiated this with respect to y. The same thing applies to this. Here there is the y attached to this. So I will differentiate that one with respect to the other variable, which is what? X. Now, if this condition holds, then it means that we can use the method of exact to solve the differential equation. So let's see. With this question, because the unknown variable are mixed with the independent variable, there is no way we can use the separable method to solve. So here, let's check the exact condition and see if it holds. So if it holds, then we will use the exact method to solve this question. All right, so we are saying that with the exact method, we need to get something like this. M of xy dx plus n of xy dy, and it should be equal to 0. So if you check very well, here we have dy over dx over here. That means if we multiply through by dx, we will get it in this form. Then after that, we can identify our m and the n. So let's see. If we multiply through by dx, I will get 2x plus 2y squared. Here is the x plus 4xy plus 3y squared, and here is the y, should be equal to this. So if you compare this one to this, here I can say that my m here will be equal to 2x plus 2y squared, and my n here will be also equal to 4xy plus 3y squared. So we are coming to check the sufficient condition for the exactness. So here I will differentiate this one, the m, with respect to the other variable. If you check the m, it is attached to what? X. So the other variable will be y. So I will differentiate that one. That is d of m with respect to y, and it should be equal to. So if you check here, I am differentiating this with respect to y. There is no y here. So I will differentiate this. And differentiation, the power will multiply this, then I will subtract 1 from that. So I will get 4y, right? Then let's check the n. So with the n2, which is this, so y is attached to that. That means I will differentiate that one with respect to the other variable, and I will get the n with respect to x. So in this case, I'm differentiating this with respect to x. I will get what? So if I check, you can see that here there is x here. So I will get 4y. Here there is no x, so there is no way I can differentiate that. And if you differentiate the constant, you will get 0. So we assume that this is a constant. Now if you compare, under the condition for the exactness, we are saying that this and this must be equal. That means die of m with respect to y should be equal to die of n with respect to x. Now if you compare, you can see that 4y is equal to 4y. Hence, we can use the exact method. So since they are exact, now what we have here is a differential equation. It means that we have a particular equation which has been differentiated with respect to x, and again it has been differentiated with respect to y. So we are coming to look for that one. We don't know that function they are talking about. So we will assume that, okay, we have a function which has been differentiated with respect to f, with respect to x. That will take this one. So that function is function f, which has been differentiated with respect to x and is equal to the first aspect, which is equal to 2x plus 2y squared. We will assume that this is equation 1. Then again, we still have a differential equation which has been, we have a equation which has been differentiated with respect to y again. And that equation is this. So here we have particular function. It has been differentiated with respect to y. So which is equal to this. And we will get 4xy plus 3y squared. So this will give us equation 2. Now right now, we are looking for that function. We don't know that function. After getting that function, it will help you to get the equation. So here we have a particular function which has been differentiated with respect to x. So it means that we need to reverse it to get the actual function. And how do we reverse differentiation? We use integration to correct it. So we will integrate both sides from equation 1. So here from equation 1, we will integrate both sides. So I will integrate here with respect to x. So I will integrate f with respect to x, which is equal to, I will also integrate the whole of this, 2x plus 2y squared. And I'm integrating that one too with respect to x. So even I can bring the x here because there is the x over here, right? Now let's integrate. So if you integrate this, you are reversing the process. What we have here is the same as integrating die f with respect to x. So if you do that, we will get the f back. So this one will give us f. So here is the same as getting the f, which is equal to, let's integrate this. So if you integrate this one with respect to x, you will add 1 to it. The power you will get, you use it to divide. So I will get 2x squared over 2 plus, there is no x here, so I have to add x. So I will get 2xy squared plus a constant because this is indefinite integral. So you need to add a constant to it. So that constant will be what? Will be c. By here, we also have another variable which is 7 as a constant, and that one is y. So this constant over there is a function in terms of y. So that means I will get y here. Now this is the main thing we are looking for. That is equation 3. The main thing you are looking for is the equation 3. So since we have a function in that function, then it means we need to look for the solution for this. So you can get this by using the second equation. So that is why we have a second equation here. So we are saying that we have this function which has been differentiated with respect to y. If you pick this one and differentiate it with respect to y, I'm sure they will be equal. Let's see whether it is true. All right. So let's differentiate equation 3 with respect to y. So if I do that, if I do that, I will get f with respect to y, and it should be equal to. So here there is no y, right? So this one will be off. Here there is y. So if I differentiate this one with respect to y, I will get 4xy plus, I am differentiating this with respect to y, so I will get c prime of y. This will give me equation 4. Now, if you check equation 2 and equation 4 correctly, you can see that they are equal. So we have this, which is equal to this. You can see clearly that this one, they are equal. So on that note, I will equate them. I will equate equation 4 and what? Equation 2. So let's do that and see. So I will get 4xy plus c prime of y, and it should be equal to the second equation, which is fxy plus 3y squared. Now we need to find the what? This function. That is, we are looking for this function. So if you check this one, you can see that here this will cancel this, right? So I'll get c prime of y is equal to y squared. So what should we do? I am looking for this, and this one is the derivative of this. So if I want to get this one back, then it means I have to reverse the process. So I will integrate here, I will integrate here. If you integrate here, this prime will take off this, so I will get c of y. which is equal to, if I integrate this, it will be 3y cubed divided by 3. So therefore, plus a certain constant, because this is indefinite integral, so plus k. Now if I do that, I'll get cy, which is equal to y cubed plus k. So this is my c. So I will substitute this, what I have over here, into where? Into this, right? So if I do that, I will get f, which is equal to x squared, because here if you simplify, you will get x squared plus 2xy squared plus my c, and my c is y cubed plus k. So we will assume that our f here is equal to a constant. That is the assumption. So f is equal to k1. Now we know that here we will get k1 equal to x squared plus 2xy squared plus y cubed plus k. So we know that if you subtract a constant from a constant, definitely you will get constant. So here we will assume that k1 minus k is equal to x squared plus 2xy squared plus y cubed. I brought this one to this side. So I assume that the whole of this will be equal to c. Therefore, x squared plus 2xy squared plus y cubed is equal to c. So this is the solution for the differential equation. Please, if you want more, just subscribe to this channel and you will get more of this. And I will also put a question over here. So if you get the answer, you will send the question to us through the comment section. Please don't forget to subscribe. So you can also try this. So you can also try 2x plus 1 plus 2y squared plus 4xy plus 3y squared y prime and is equal to 0. So find the general solution for this. By here, you can see that before you can find the solution, check whether it is exact. If it is exact, you can use the same approach to get it. Please don't forget to subscribe to this channel, and thank you for watching us.